Welcome back, everybody. Quick video today. We talked about simplifying radicals the other day. What we're going to talk about today are some other operations you can use radicals for. So simplifying radicals, we simplify them, but we also talked about multiplying radicals. That was how we simplified at the very end when we combined whole numbers with whole numbers, radicals with radicals. So just to remind you, multiplying radicals, the rules work exactly the same as if you were multiplying integers. With dividing radicals, it's going to work the same way too, but there's going to be one special case where you're going to have to do something a little different. We're going to talk about that today. We're also going to talk about adding and subtracting radicals, and that's actually where we're going to start. So if I gave you 2 radical 2 plus 4 radical 3 plus 6 radical 2 plus 2 radical 3 plus 10 radical 5, that looks a lot more difficult than it actually is. I want you to imagine, though, that all of the radical 2's there were x's, all the radical 3's there were y's, and all the radical 5's there were z's. Think about what you would do to simplify this. Well, you would combine like terms. So you'd put the 2x and the 6x together and you'd get 8x. You'd put the 4y and the 2y together and you'd get 6y, and you'd get the 10z at the very end. And that would be it. That would be as simplified as you could make it. We're going to do the same thing when adding and subtracting radicals. So 2 radical 2 plus 6 radical 2, we want to leave the radical 2 alone. We're just going to add the number in front, the coefficient. So 2 plus 6 is 8. We're now going to have 8 radical 2's. We're going to do the same thing with the radical 3's. We have 4 radical 3's here. We have 2 radical 3's there. 4 plus 2 is 6. So we're going to have 6 radical 3's. And then we have 10 radical 5's that we can't combine with anything, so we just leave it at the end. So again, combine like terms. You want to put all the radical 2's together, all the radical 3's together, all the radical 5's together, but they have to have the same number underneath the radical sign for you to combine them. If they don't, you have to leave them apart. So that's the whole idea behind adding and subtracting radicals. Dividing radicals, sometimes it's pretty easy. You might get a problem like this, radical 20 divided by radical 10. Well, 20 divided by 10 is 2, so we would get radical 2. That's what we would get. Because you could think of that radical 20 as radical 2 times radical 10, and the radical 10's would cancel out. So division's really easy, but sometimes you get problems that aren't so easy. They're what's known as rationalizing the denominator. So here's the thing. We talked about a radical being a shorthand way of writing a number that we're going to find, a decimal that's going to continue on for a while, because we need to take that decimal and multiply it by itself to get a whole number. So if we know it's a decimal that goes on forever, we don't really know exactly how big it is because it's still going. We don't know when it ends. So we can't divide by it. So whenever we have a radical in the denominator, we have to get that to be a rational number. It means it needs to end. We need to figure out exactly what it is. So in order to do that, what we're going to do is we're going to follow a couple simple steps. The first step we're going to follow is going to be to rationalize the denominator, which sounds a lot harder than it is. But really all it's asking us to do is to multiply both the numerator and the denominator by whatever the radical is in the denominator. So in that case, it's going to be radical 15. Now we're going to change this problem down here so we can see what's going on there. So what we're going to do is we're going to multiply radical 15 by the top and the bottom. Over here, the radicals multiply together, so we're still going to have 8, but it's going to be 8 radical 45. On the bottom, radical 15 times itself becomes 15, and that's all we have to worry about. The second step we're going to do is simplify the radical. So that radical 45, we want to simplify it. So if I wrote that out, if I wrote that over here, square root of 45, we would break it down. You would get 9 and 5. The 9 would break down to 3 and 3. So we would have radical 3, and radical 5. So what we're going to do is we're going to take the 2 radical 3's, we're going to put them together, we'll get a whole 3 and a radical 5. We're going to have that 3 radical 5, and that's going to replace the radical 45 over here. So we're still going to have an 8, we're still going to have a 15, but that radical 45 will now become 3 radical 5. So we have 8 times 3 radical 5. The second step, or the third step we're going to do is we're going to simplify the numerator. So, 8 times 3 we know is 24, so we're going to get 24 radical 5 over 15. So that's all we have to do. We just check the whole numbers. If we can multiply them together, we do that. And then the final thing we're going to do is we're going to simplify the fraction. What I mean by that is we want to look at just the whole numbers. 24 over 15 and ask ourselves, can I simplify that fraction? Well, I know I can pull out a 3 from both of them, so I'm going to get 8 radical 5 over 5. And that's going to be our answer. So that's all we have to do. So it looks long, it looks hard, but it's not that bad. Here's all we're doing. Rationalize the denominator. Multiply the top and the bottom by the radical that we have. That's easy enough. The next step, we want to simplify the radical. You already know how to do that. The next step, we're just multiplying whole numbers in the numerator. And the final step, we're just simplifying one fraction. That's it. So we'll try it for this problem down below. We have radical 21. We want to multiply both sides by radical 21, top and the bottom. When we do that, we're going to have radical 21 times radical 21 is 21. So we're going to have 2 times 21, which is 42. Up here, we're going to have 3, and then we're going to do 20 times 21, which is going to get us 420, I believe. So we're going to have 3 radical 420. Now what we're going to want to do is we're going to simplify that 420. So I'm going to put it right over here. You know what? Why don't I erase this? We're going to put 420, and we're going to start breaking it apart. So we could do 42 and 10. We could break up the 42 into a 7 and a 6. We can break up the 10 into a 5 and a 2. We can break up the 6 into a 3 and a 2. So when we're done, we're going to have a radical 7, a radical 3, a radical 2, a radical 5, and a radical 2. So what we want to do is we want to pull out that radical 2 will become a whole number 2. We do 7 times 3 is 21, times 5 is going to give us 105. So we're going to get 2 radical 105. And that's as far as we're going to be able to go with it. So what we're going to have is we still have the 3, we still have the 42, but now this radical 420 will become 2 radical 105. So our next step, now that we've simplified the radical, simplify the numerator, we're going to get 6 radical 105 over 42. And then we want to simplify the fraction. 6 over 42 is the same thing as 1 over 7. So we're going to get the square root of 105 over 7. And that's it. We're done. Those are about as hard as you'll see a problem where you have to rationalize the denominator. Sometimes you can skip these steps. For instance, if we multiplied by something and the radical didn't need to be simplified, we got like a radical 7 or something like that, that might be it. We might not need to simplify any further. But go through your list, check just to make sure whether you need to or not. But other than that, that's it. If you need help, you know the routine. Rewind, or I'll be around for extra help at some point. Hopefully you know when. Until then, I'll see you next time.